Hello students, welcome back to my YouTube channel. So in this video what I'm going to be talking is about matrices. So I have extracted two questions from the past papers. One is from 2019 and another from 2018. So as you can see, this question was extracted from the 2019 past paper and this question was extracted from the 2018 past paper. So usually in combined mathematics 1 paper, as the 13th A question, there is a question in matrices. So you should know the basics of matrices and how to do questions related to matrices, right? So before getting started with this past paper discussion, let me give you a brief introduction to matrices and basic operations in matrices, right? So okay, so before getting started, we have to first know what a matrix is, right? So let me create some space here. Okay, so matrix. Okay, right. So matrix is nothing but matrix is a rectangular array of numbers, right? So nobody will ask you to define the term matrix, but you should know the definition so that you can go ahead with this, right? So a rectangular array of numbers, right? So there will be a rectangular array. Array means array will contains columns and rows, but I will say row and columns, right? Row and columns, right? So if I take a matrix A, then it will contain some elements. So we will denote it as A, right? A up to A. And here also A up to A. Now this element A, this element A is in the first row, first column. So I will denote it as A11. Then again this element or this entry is in the first row and second column, right? So first row and second column. So I will denote it as A12. Always in a matrix, when we define or when we name the entries, first we have to mention the number of row in which it occupies and then number of column in which it occupies, right? Okay, then let's say the dimension of the matrix is let's say m cross n. So this m means number of rows and this n means number of columns, right? So if I have n number of columns, then it will be a1n. Okay, so the last entry of this row is a1n, right? So which means it occupies in the first row and in the nth column. Likewise, we can denote it as it lies in the second row, first column, then a22, then a23 and a2n. Likewise, we can denote. Then let's say we have m number of rows. So this is the first entry of this last row. So it will be am1, okay, because it lies in the first column, and am2 up to amn. Okay, so this is how we denote explicitly. This is how we denote the matrices explicitly. Okay, so then now we will move to, okay, for example, now let's take an example. Okay, so if A is a 2 by 2 matrix, then it will have 4 elements, right? So let's say 3, 2, 4, minus 1. Okay, so this is a matrix. Okay, now if matrix B is let's say the size or the dimension of the matrix is 2 by 1. So which means it has 2 rows and 1 column. So this is a column matrix, right? So we have several classification of matrices. So we have row matrix. Row matrix mean it has only 1 row. Okay, so this is a column matrix. Okay, so let's say, for example, 2 1. Okay, so it has 2 rows and 1 column. So this is called a column matrix. Okay, now let's say C is a matrix whose dimension is 1 by 3. So this is a row matrix. Okay, so let's say minus 1, 2, 3 are the entries of this matrix C. Then it has only one row but 3 columns. Okay, so this is a row matrix. Okay, now we will see the basic operations in matrices. Now first we have to know the addition of two matrices. Okay, so if we have to add two matrices, then the dimension of those two matrices should be equal, right? For example, let's say we have a matrix A and we have matrix B. Okay, so if now the condition should be the dimension of these two matrices should be the same, which means the size of this matrix and the size of this matrix B should be equal. For example, if I have A is equal to 2, 1, 3, 0, then B is equal to let's say minus 3, 1, 0, 0. Okay, now the dimension of this matrix is 2 by 2. Here also 2 by 2. So the matrices with same size can be added or subtracted. Okay, so addition or subtraction. Okay, right. Now when we add or subtract two matrices, then you have to simply add or subtract the corresponding element. Corresponding element in the sense, if we are considering the first this entry, then the entry corresponding to this entry in the second matrix is this, right? So this is A11. This is also A11. So this is now this is A11. This is A12. This is A21. This is A22. Now this is A11. This is A12. This is A21. This is A22. So you have to just add the corresponding entries. Now if I want to find A plus B, then this is very simple. You have to just add these corresponding entries. So it will be 2, and when you are adding, you have to consider the symbol, the sign also. 2 minus 3, then this plus this, so 1 plus 1, again 3 plus 0, and again 0 plus 0. So this will be again equal to minus 1, 2, 3, 0. Okay, now let's say we have a matrix, let's say whose dimension is 2 by 1. So 2 by 1 in the sense, let's say 2, 3. Okay, so if you ask if we can add A and C, then this is not possible because the dimension of these two matrices are not same. Okay, right. And the same applies for subtraction also. Now we will see the multiplication of two matrices. Okay, multiplication of two matrices. Okay, now here the condition is the matrices should be compatible. Compatible in the sense, for example, let's say we have a matrix A whose dimension is m cross n, and we have to add multiply this matrix with another matrix B, let's say whose my dimension of this matrix is n cross p. In this scenario only we will get A, B. Okay, and then the dimension of the matrix resultant matrix will be m cross p. Okay, now the compatible means the number of columns in the first matrix should be equal to the number of rows in the second matrix. Okay, so then the dimension of the resultant matrix will be m cross p. Okay, now this might be confusing, but when we do question you can easily understand. Now let's take an example of 3 by 2 matrix. Okay, so A is equal to 2 1 0 1 1 2. Okay, so this is A, and we will take another matrix B. So this will be, let's say, 2 by 3. So 0 1 2 2 1 0. Okay, now we can multiply this A and B. So the dimension of this matrix is 3 by 2, then this is 2 by 3. Now if you are asked to multiply two matrices, first you have to check whether it is they are compatible or not. So compatible means the number of columns in the first matrix should be equal to the number of rows in the second matrix. So this is 2, this is also 2. So the resultant matrix will have the dimension of 3 by 3. Okay, 3 by 3. So AB, let's say C is equal to AB, then the dimension of C would be equal to 3 by 3. Ultimately you will get a matrix with size 3. Okay, now we will do this question. Okay, now how to multiply these two matrices? Okay, I will tell you. Okay, so A B means you have to just write down the matrices separately. 2 1 0 1 1 2, then 0 1 2 2 1 0. Okay, now what you have to do is simply you have to take the row of the first matrix and multiply it by the columns with the second matrix. Then you have to put, okay, let me just, okay, so now you will get a 3 by 3 matrix. Okay, 3 by 3 matrix. So here 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 you should have some entries. Okay, you should have some entries. For this place you should know what entry would come. For getting that entry, you just want to multiply the row of the first matrix and the columns of the second matrix, and you have to just multiply the corresponding elements, and then the multiplication of the corresponding individual element should be added. Okay, so which means 2 1 this, right? So 2 times 0, which is 0, plus again 1 times 2, that is 2, that is equal to 2. Do you understand? So here 2 will come. So here you just want to write 2. Again you have to take you have to find out the entry coming here. For that also you have to take the first row and the first row of the first matrix and the second column of the second matrix. Okay, so you just want to multiply this by this, 2 plus 1 by 1. So 2 plus 1 3. Okay, so you should write 3 here. Again this should be multiplied by this. So 2 times 2, 4, plus 2 times 2 plus 1 times 0. So 4 is the answer. Okay, 4. Again, for finding out the entry coming here, you should take the second row of the first matrix and the first column of the second matrix. So 0 times 0, 0, plus 1 times 2, 2. So 2. So here 2. Then again, to find out the entry coming here, you have to take this row and this column. So 0 times 0, 0 plus 1, that would be 1. Again, now again this by this. Okay, this by this. So 0 plus 0, 0. Likewise, for finding out the entries in the third row of the resultant matrix, you have to consider the third row of the first matrix and the all the columns of the second matrix. Okay, so this by this will give you the A3 1. Okay, 0 plus 2, that would be 4. Again, this by this, 1 by 1 plus 2, 3. Again, this by this, 2. Okay, so this is how matrix multiplication should be done. And now we will directly move to the questions, and if you need any theory related stuff, I will explain. Okay, I will explain on the way. Let me erase all these stuffs. Okay, now we will try to answer the question that came in 2019. So we will just read it. Okay, let A is equal to this, B is equal to this, C is equal to this. Now according to what we have studied, now we have to just see the dimension of the matrix A, B and C. So the dimension is, we have 2 rows and 3 columns. So the dimension of these 3 matrices is 2 by 3. Okay, such that AB transpose. Okay, now we have another term called transpose. Transpose of a matrix, right? So which is denoted as A transpose. Now if we have a matrix A, and the transpose of a matrix is just nothing but, you have to just interchange the rows and columns. Okay, for example, let's say we have a matrix A is equal to A, B, C, D. Then in A transpose, the row of matrix A becomes the column. Okay, the first row will become the first column, A, B. Then the second row will become the second column. Okay, C, D. Now let's say we have a matrix B is equal to A, B, C, D, E, F. Okay, now B transpose will be, now you have to just write down the rows and columns other way around. So this row becomes the column, so A, B, C. Here this becomes the second column, D, E, F. Now you see here there is a trend. Now if the matrix is square, right, so we call square matrix mean the number of rows and the number of columns are same. Now if I write down the transpose of a square matrix, again it becomes, the size doesn't change. Okay, size doesn't change for A transpose in a square matrix. But this is not a square matrix, so the size has changed. Okay, here the size is 2 by 3, but here the size is 3 by 2. It has interchanged. It has interchanged. Okay, so with that idea, we will just okay, with that idea, we will just continue the question. So B matrices such that AB is equal to, AB transpose is equal to C, where AB belongs to R. Show that A is equal to 2 and B is equal to 2. Now this is our question, and this is a hint, and this is the data given. So using these, we have to find out the values for A and B. Okay, so they are telling AB transpose. So A, B transpose mean the transpose of B is found and then it is multiplied by A. So first thing that we have to do is to find out the B transpose, right? So B transpose, so B is here. So B transpose is what? B transpose is, you have to just interchange the rows and columns in matrix B. 2, 1, 3, 1 minus A, 4. Okay, then you have to multiply this by A. So A B transpose is equal to, now A is equal to A 0 minus 1 0 minus 1 0, then uh, 2 1 1 minus A 3 4. Okay, now we have to multiply this. So we have studied how to multiply, right? So you have to just take this row and this column. So 2a, now we have 0, right? So we don't need to write that. So minus 1 into 3, 2a minus 3. Again you have to consider this row and this column. So a plus 0 minus 4, a minus 4. Then again you have to consider this and this, 0 minus 1, 0, right? Minus 1. Then again this row and this column, so minus a. Okay, so they are telling AB transpose is equal to C. So this is the resultant matrix for AB transpose. So this should be equal to C, right? So this becomes B minus 2 minus 1 B plus 1. So now this matrix and this matrix are same. So if we have there is a theory, if matrix A is equal to matrix B, then the corresponding elements in matrix A and B are same. Okay, for example, let's say we have a 2 by 2 matrix. So this is A B C D, then this is P Q R S. Then we will say A is equal to P, A is equal to P, B is equal to Q, C is equal to R, and D is equal to S. So the same theory is going to be applied here. So you can just write this as okay. So what we can tell is, let me use a different color. Okay, so what you can tell is 2a minus 3 is equal to b. Then again a minus 4 is equal to minus 2, right? So you have to equate all the corresponding entries. For those equations you might have some partial marks. Okay, so minus 1 is equal to minus 1, that is obvious. Now you can skip this, and minus a is equal to b plus 1. So this is equation 1, this is equation 2, and this is equation 3. So from equation 2 you can tell a is equal to 2. Then if you consider any of the equation, now for easiness I am just considering the third equation. If I substitute the value for a in the third equation, then I will get b is equal to minus 2 is equal to b plus 1. So from this I can tell b is equal to minus 3. Okay, b is equal to minus 3. Let's check. Oh, we have done something wrong somewhere. Okay, so I'm sorry, because while I was cutting this row, so here we have a minus. Okay, so here this was multiplied by this, okay, to find out this. So here minus 1, here minus a, so it should be plus a. Okay, I'm really sorry for that. So here plus a is equal to b plus 1. So here we can tell 2 is equal to b plus 1. So from this b is equal to 1. Okay, so there was a small mistake. Now we will continue the question. We have just found out A and B. Okay. Let me just erase all of these because not necessary. Okay. Now show also that C inverse does not exist. Right. C inverse means inverse of a matrix. Now we have to know what inverse of a matrix. Okay. Now if a matrix A is non-singular, then it is called, this is invertible. Invertible in the sense inverse of matrix will exist. Now for determining whether a matrix has inverse or not, we have to just find out determinant. Okay. So determinant is a scalar related to a matrix where you have to calculate it, right? For example, let's say if we have now in A-level syllabus, you just want to find out the determinant of a 2 by 2 matrix. So I am just going to take an example. A is equal to A, B, C, D. Then the determinant of A is denoted using this parallel lines. So this will become, you have to just multiply AD minus this, right? So this is called principal diagonal, the multiplication of the principal diagonal and the second diagonal. Okay, now this is like secondary diagonal. Okay, so CB. So this is called the determinant. Now if A, determinant of A is equal to 0, then we can say the matrix A is singular. Singular in the sense, for this matrix we cannot define inverse. Okay, so what you have to just do is C inverse. Okay, so now C is given and we have found out the value for this B and A. So C can be written as 2 minus 1 and 3. Okay, now we have to just find out the determinant of C is equal to, just multiply this 2 by 3 minus 1 into 2. Okay, minus 1 into 2. Wait. Okay, so here I'm sorry, A is equal to 2, B is equal to 1. Okay, you should be very careful. So C is equal to 1 minus 2 minus 1 and 2. So here this is wrong. Okay, here this is wrong. So mod of C, which means the determinant of C is equal to 1 times 2 minus 1 minus 1 into minus 2. So 2 minus 2 is equal to 0. So from this you can tell that so since the determinant becomes 0, we can tell that the inverse will not exist for this C. Okay, so that is okay, that's done. Now we will go for the latter part of this question. Okay, so they are telling let P is equal to half times C minus 2i. Write down P inverse. Okay, they are telling to write down P inverse. So this is very simple because we know the value for C and I. So now I means, now they are telling I is a identity matrix. So identity matrix mean the principal diagonal elements will have 1 and the rest will 0. Okay, now if this is a 2 by 2 identity matrix, then only this diagonal will have entries as 1, then the rest will be having zeros. Okay, now if I is equal to size by 3, now I is a square matrix, so 1 1 1 0 0 0 0 0 0. So this is identity matrix. Okay. Now this is very simple. So half, within brackets you can write down this c. C is equal to 1 minus 2 minus 1 and 2. Okay, minus 2 into I means 1 1 0 0. You should know this because they have not given I, right? They have not given I, and you shouldn't be thinking what is I. I is not given, so how can I do this question? You can't think like that. Okay, so now if you simplify this, you will get half into you have to just work out this parenthesis first. So 1 minus 2. Okay, I'm just directly writing because only if I multiply this by 2, this becomes 2 and this becomes 2, but you can't do like that. Okay, I'm just writing. So 1 minus 2, then minus 2 plus 0 minus 0. So minus 2 minus 0 means minus 2. So minus 1, then again 2 minus 2, so becomes 0. So it will be equal to half minus 1 minus 1 2 minus 2 minus 2 0. Okay, minus 2 0. Now what we have to do is we have found out P, that's all, and now we have to find out P inverse, right? So P is this, so we have to find out P inverse. Okay, P inverse. Now I have to define the determinant of this matrix. Okay, so determinant of this matrix is determinant of P is equal to this one. I can write in this way: minus 1 times 0 minus 1 minus 1 into minus 2, so minus 2. Okay, minus 2. So P inverse is equal to 1 over determinant of P into, then you have to just interchange these elements, and half, the coefficient is there, so you should write down that half also here. So here you have to just interchange these two entries. 0 becomes here and minus 1 becomes here, and you have to negate these values without changing. So 2 and 1. Okay, so this will become a half into minus 2 0 2 1 minus 1. So this will be equal to minus 1 into this, so 0 2 1 minus 1. This will become 0 minus 2 1 minus 1 and plus 1. Okay, so this is the answer. So this is nothing but P inverse. Now we have found out P inverse is 0 is minus 2 minus 1 and 1. Okay, now again we will move to the last part. Before that, let me create some space here. I don't know if we will require this P inverse. Let me write down P inverse else. P inverse we have found out as 0 minus 2 minus 1 and 1. Okay, now I will erase these steps. Okay, now n, find the matrix n. Now we have done up to this point, and now we will go for this. Find the matrix Q such that 2pq plus 3i is equal to p minus I, where I is the identity matrix. Okay. Again, we have to eliminate this p, right? So you should know p into p inverse will give I. Then there is another thing. If you multiply a matrix by identity matrix, then it will result the same matrix. Okay. So these 2 points you should bear in mind. So if I want to get rid of this p, then I have to multiply the entire equation by p inverse, right? So it will become 2 p inverse into I, p inverse into p. Now p into p inverse into q plus 3i is equal to p into p inverse into I minus I into p inverse. So it will become p inverse. Okay, so it becomes 2, this is I, this portion becomes I, then this is another matrix, so 2 into q plus 3i, it will result the same matrix. Okay, instead of A we have this matrix expression. Okay, a combination of matrices. So this will become I minus p inverse. So we know that I minus p inverse we have already found out, so we can just substitute 1 1 0 0, then minus 0 minus 2 minus 1 1, which will be equal to 1 2, then again minus 1, no plus 1, then again 1 minus 1 0. Okay, now from this I can write 2 into q plus 3i is equal to what? 1 2 1 0. So q plus 3i is equal to half into this 1 2 1 0. Now I need q, right? So I need q. I need q. For that I have to just bring this 3i to the next side. So that will be equal to how can I write this? Anyway, half into 1 2 1 0 minus 3. Instead of I can put 1 0 0 1. Okay, so again it will be like I have to just substitute, I mean I have to just simplify this. So half minus 3, then again 1 minus 0, then again half minus 0, that would be half, again 0 0 minus 3, 0 minus 3 minus 3. So this will be equal to what I'm writing here. Okay, I'm just writing below this line. So this will be equal to 6 minus 5 by 3, minus 5 by 3, I'm sorry, minus 5 by 2. Okay, I'm always making silly mistakes, I don't know. 1 this not 1 is not here, half, then minus 3. So this is the answer for q, right? So we have found out q also. So that's all for that question. Now we will move to the question that came in 2018. Let me I will just quickly explain this question. Okay, so this question is also coming from matrices. So two matrices are given. One, okay, so in the matrix we have some unknown values. So in terms of A, So where A belongs to real number, find the matrix P defined by P is equal to AB. Now P is also given. Find the matrix P defined by P is equal to AB and show. Okay. Now we have to find out P, which is multiplication of A and B, and in the P the entries will be in terms of A. Okay. So what you have to do is you have to simply take P is equal to AB, then A is given 1 1 0, 2 4 minus 1, B is given 3 2A minus 1 0 1 3A. Okay, now this is 2 by 3, this is 3 by 2, so the resultant matrix will be something 2 by 2. Okay, so you have to just multiply this by this, so 3 minus 1 2. Okay, then this by this, so 2a, that's all, 2a, then again this by this, 6 minus 4, 6 minus 4 minus 1, so 1. Again this by this, 4a minus 3a a. So P is this matrix, and P inverse does not exist. We have to tell that P inverse does not exist. For that we have to just find out the determinant of P, which is equal to 2a minus 2a, which is equal to 0. So P is a singular matrix. Okay, now show that if P into half, then we have to find out the value for A. For that they have given a relationship, P into 1 2 is equal to 5 into 2 1 now. Okay. Now P is 2a 1a into 1 2, that would be equal to 10 5. Okay, because this is scalar multiplication. So scalar multiplication of matrices we haven't discussed. So for example, if we have Ka, then let's say A is equal to A B C D, then this would be equal to Ka, Kb, Kc and Kd. Okay, you just want to multiply each entries by the scalar. So now you have to just, from this you can write 2 plus 4a, 2 plus 4a, then 1 plus 2a, 1 plus 2a is equal to 10 5. From this you can tell that 2 plus 4a is equal to 10, then a is equal to 2. Okay, so you just simplify this. Okay, that is your. Now with this value, so we have to substitute the values in the matrix. Let me just erase all this stuff. So they are they are telling like now let me use green color. Do you all like green? Okay, now write down. Okay, so this, with this value, no, it's not, I don't know, this is okay here. With this, let Q is equal to P plus I, where I is a now we have to find out Q first, right? So we have found out P is equal to I think this one, right? So P is equal to what? P is equal to 2a, 2 1 4 2. Yes. Okay, So p plus I means you just want to add p plus I is equal to 1 1 0 0. So it will become 3 4 1 3. Okay, 3 4 1 3. Now write down q inverse. Now q inverse should be written. So for that we have to find out the mod of q, which is determinant of q. So 3 times 3, 9 minus 4, which is equal to 5, which is equal to 5. So now q inverse is equal to 1 over determinant of q into, you just want to if you interchange these numbers, then okay, minus 4 minus 1. So q inverse is equal to 1 divided by 5, 3 minus 4, 1 3. Okay. In the answer there is a minus. Have we done any mistake here? Okay. So here there is a minus. I forgot to put this minus here. Okay. So this is how you also will lose marks in the examination. You know everything. But a small mistake in the sign can ruin your life. Okay. So you should be very careful. Right. Okay. Now we can take some spaces here. And they are telling like write down q inverse. Okay, now find r such that a into a transpose minus half into r is equal to 1 by 5 q inverse. Okay, so now we have to find out r. So I have to bring r to the one side. Okay, so half r is equal to, I'm just bringing this. Okay, a into at minus 1 by 5 q inverse. Okay, now we have to know there is a theory, k into a holding inverse would be equal to 1 divided by k into a inverse. So if I apply this here now, this is like the inverse of k is the reciprocal of k, right? So this will become, now I can even multiply this 2, right? R is equal to 2a into a transpose minus the reciprocal of 5 is 1 over 1/5 is 5. So I have to just again multiply by 2. It will become 10 q inverse. Now we have found out q inverse. Already we have found out q inverse. Then R is equal to 2 times a 1 1 0 2 4 minus 1. Then the transpose of that matrix is 1 1 0 2 4 minus 1 minus 10 into 1 by 5. Then 3 minus 4 minus 1 3. So if I just simplify this, I will get R. Okay. So if you just simplify this, I will get 2 times, now 1 1 1 again 2 plus 4 6. Okay, then 2 plus 4 6, again 6, again 4 plus 16 21 21. Okay, minus 2 2 into 3 minus 4 minus 1 3. Again I can take 2 out, so 1 minus 3 minus 2, 6 minus 4, 6 plus 4 10, again 6 minus 1 5, then again 2 minus 6 2 minus 3 minus 1. So this is the answer. Okay. I'm sorry, this is not one. No, so 21 minus 3 18. Okay, so this is the answer, and if you want you can give the answer in this way also. Minus 4 20 10 36. Okay, 1 minus 3. Okay, so this is the R matrix. Okay, hope you enjoyed this video, and we will meet in another video. And if you haven't subscribed to my channel, please subscribe, and if you can find this video useful, you can share with your friends also. So we'll meet in the next video. Till then, bye.